Okay, so I'm going to work on the volume of a region about y equals -1. I am not going to say which method to find the volume, all right? And I'm going to use the curves of parabola y equals x squared on the vertical and x equals y squared, parabola on its side. We're going to go about y equals -1, a horizontal line just below the x-axis. I don't want to spend time with the graphing, so there's a graph. And the region R then would be this little yellow area right in here. And that's going to spin and be around y equals -1. So we have to decide which way to do the volume. There would be the tried and true method would be to do it this way. All right? And just say, we obviously are going to have a washer shape, okay? Because there will be an inside and an outside radius, all right? And there's a dx thickness there. And we can do it that way, and that's one method we're going to do. The other way, I can tell you to do this in cylindrical shells. And then the hard part about this is that we recognize our cylindrical shell formula of a to b of 2 pi x dx, f of x dx goes about the y-axis. Well, this is horizontal. So the other way to calculate the volume of this problem is to do it with the formula here and go about the y. All right, and we will do both methods here, set them up, and use a calculator to get the answer and make sure that they match. So let's do it the old-fashioned way first, which I think is going to be a little bit quicker. We recognize immediately that 0, 0 is an intersection, and guess and check, it's 1. All right, now here's the problem. I know if I'm going to go with dx, I'm going to have y equals, so I know this is y equals the square root of x on top, and y equals negative square root of x on the bottom. So I get an integral here from 0 to 1, and it's a washer, so pi r outside squared minus pi r inside squared dx. I'll move this to the side for now. Bring the pi out. And then the outside radius is the 1 plus the y distance, so 1 plus, and it goes to the other curve, so 1 plus square root of x, quantity squared, minus 1 plus x squared, the inside radius, which would be this and this. All right? And when I get this done, this is the integral set up but not evaluated. And that's pretty common for me to tell. You could do this by hand, both binomials squared returning trinomials, and it would be doable. All right? And there will be an answer for this. And we're going to do this, we'll do the calculator work at the end. So we'll group all this and say, yeah, this is the area or the volume of this figure. And we'll put that over here. The other way to do this is with cylindrical shells. All right? And if we're going to do cylindrical shells, we have to recognize that the integral of this thing is going to be from this 0 and not this one, but from the origin to this one. And I'd put the 2 pi outside immediately. And we recognize that the cylindrical shell here, the cylinder, would be right here, right? So it's 2 pi for the circumference, which we already wrote on the outside. And then the radius here would be this distance, which is 1 plus the y distance. So our radius for y is 1 plus y, or y plus 1. And our f of y, this distance here, all right? This distance here, again, maybe I make it a little bit easier to see by moving some stuff off. This purple line distance right there, all right, is going to be the right curve minus the left curve. But we should automatically see that we got a problem here. So I'll solve this, and I get that plus or minus square root of y, but the right side, all right, that we take the square root of both sides, we get x plus or minus x, and then square root of y. So my distance here is the right curve, which I know is square root of y, minus the left curve, which is y squared dy. All right. And that's the cylindrical shell method. Now the question simply becomes, are these both the same values? So let's group all this. All right, and let's pull up a calculator. We're going to put these up and we're going to bring a calculator in. All right, so I've moved some equations around, and you'll see over here that this one is the old method with the washer, and I wrote in pi times the integral from 0 to 1 of the outside radius squared minus the inside radius squared. Did it all with respect to x, and then dx and my TI-84, and I push the button, and it tells me 3.03687422. And then I did the other one before I did this. So we go second again. I'm using second entry to get these other equations. And this one, and you just got to make sure you get the right things. It's 2 pi, right? And I'm looking over here. 2 pi from 0 to 1 of 1 plus y. But we don't use y on the TIs. We use the x again, so I'm changing all the y's. X to the 0.5 power, or square root of x would do the same thing. Minus x squared dx. And again, if I hit enter, I get an answer of 3.03687422. Exactly the same answer. Again, cylindrical shells or discs and washers or perpendicular shapes. Now remember, cylindrical shells will only work on shapes that are revolved as circles because it is a cylinder. Whereas this method will work with any cross-sectional shape. And the AP test will absolutely ask something besides circles. Keep practicing. All right, and use this for review. Happy APing.